Games do not like when you spend a long time in them doing absolutely nothing. They are built with the expectation that you are constantly exploring, interacting, or progressing through their worlds. But what happens when you defy these expectations? When instead you simply stay idle and do nothing at all? There are actually 4 of these bugs in Mario 64 that I am going to show you today that I am not sure anyone knew of before this video got published. We'll find out today, and you can thank this video sponsor, Squarespace, for bringing us together today. Games often have to keep track of time, and whenever a game has to keep track of time, you have a silent, infinitely incrementing counter running in the background. There is an inherent issue behind this. Computers, despite having crazy capabilities, are fundamentally unable to deal with infinity. Their memory isn't infinite, meaning every timer we can program will eventually reach its maximum capacity. And when that happens, odd things occur. Counters loop around, values overflow, and other unexpected behaviors emerge from the depths of the game's logic.
This is it, Pac-Man players. We're having the final level.
Mario 64 is one of the most documented and analyzed games in existence. Yet even in this extensively explored universe, I doubt anyone knows about all the mysteries. For example, this painting right here. Nothing special or wrong with it, right? Well, if Mario remains in this room without any player input necessary for about 6.5 days, the painting abruptly stops rippling. Alright, so why does it take such an odd amount of time? Did they program it like that? Or is this something inherent to computers? Does this happen in other games too? As it turns out, time can break many things, and not just in Mario 64. So while I am going to talk about Mario 64 here, this game is not unique for having this problem at all. For example, while writing the script, I randomly stumbled upon this Unreal Engine 5 code snippet that makes sound effects loop for just under 3 hours. This type of bug is everywhere. But let's talk about why this happens. When programmers want values that can grow to an unlimited size, they often look to floating point numbers, or floats for short. These are special numbers. Instead of storing as straightforward numeric values, floats carefully divide their storage into 2 parts, an exponent and a multiplier. Take for example the floating point value 0x40000000. It doesn't directly store the number 2, yet it perfectly represents it. Specifically, it stands for 2 raised to the power of 1 multiplied by 1, which results in exactly 2. This floating point converter here visualizes this really well for us. We can edit the exponent with the checkboxes on the left, and we can edit the number it multiplies with on the right. Again, each checkbox representing 1 bit. The largest number we can present that way with the float number is this number here, which is so incomprehensibly large that if I said it out loud, this video would be a whole extra minute. If we incremented a counter by 1 for every in-game frame that happens in Mario 64, it would take longer to max out this counter than the universe has existed. Despite this, personally, I think floats are way overused and definitely should not be used to store an infinitely accumulating value such as time. And to be fair, Mario 64 did not use floats like that very often. But one place they did use floats to accumulate time is the paintings. The Dia Dog painting is a good argument against using floats for incrementing values. But Mario's in this room with this painting. Every frame, it adds floating point value 1 to the timer, and that's a ticking time bomb. Look at this. The moment the timer hits precisely 16,770,216 frames, everything breaks down. At that exact time, the floating point representation reaches a critical threshold. Its exponent has grown large enough that the smallest increment it can represent is suddenly greater than 1. At that point, adding a value of 1 becomes impossible. The system tries, but there is no floating point representation for 16,777,217. So it's round down to the nearest number it can represent, which happens to be the 16,777,216 we started with. This results in the addition not changing the timer value by a single bit, and the timer stops incrementing entirely all of a sudden. And if you convert frames to days, this number lands us at just around 6.5 days. And this is not just an issue for an old N64 hardware. This format for floating point numbers is still used in games nowadays, which is why I expect this bug to be omnipresent across many video games. And just to prove this bug is real, I've had my Nintendo 64 run for 6.5 days. And look what happened. That is so cool. The painting is completely still. And while I did compute that it would take 6 days, 11 hours, 20 minutes and 40 seconds before it stops, this game is actually so hilariously unoptimized that being in this empty room with nothing but the painting doesn't run at 30 FPS, so I had to wait around 6 days and 12 hours. But the painting is stopped. Now there's something funny to this. On Wii Virtual Console, there's a floating point rounding error in the emulation code. Instead of properly rounding numbers to their nearest representation, it always rounds towards 0. And yes, Virtual Console is just emulation, even if Nintendo will never admit to that. This bug is completely invisible in regular gameplay, but if you spend around a couple days in Bowser and the Fire Sea, the rounding error accumulates on this moving platform here, and the platform will be slowly moving higher and higher until it reaches a height of 0, which would be on the second floor. This actually allows you to beat the game entirely without jumping on Wii Virtual Console, and I'm pretty sure someone has done this before, but I couldn't find the video for proof. Rather disappointingly though, I don't think this rounding bug affects the paintings in any way. And while it's not strictly a timer bug, I think the same rounding bug might also apply to Fly Guys, which will slowly oscillate towards 0 in the Y direction, but I'm basing this guess on the code alone, because I don't actually have a Wii Virtual Console to test with. If you have one, I'd appreciate if you could try and leave a comment and tell me whether this bug actually happens. So, what's going on with the other paintings? Only a few select paintings have the ripple stopping behavior we've seen in Dia Dia Dogs. Specifically, it's only the permanently wobbling ones, which would be the Dia Dia Dogs painting, the entrance to Hazy Maze Cave, and the Metal Gap entrance painting. Why just these? Well, on all the other paintings, Nintendo kept in mind to reset their timers whenever their individual ripple animations are triggered, which makes this bug impossible. As of now, there's no known way to trigger continuous rippling on these other paintings, and I don't see a way in the code around that either, but who knows. Since I literally see floats used exactly like this in video games, I would not be surprised if almost every modern game had a strange bug like this happening if you spend days or even months in some areas. Now, while the paintings are clearly special cases, most other timers in Mario 64 actually use a much better method: integer-based timers. Unlike floats, integers simply count whole numbers directly, starting from 0 and incrementing upwards with perfect precision. Unsigned integers can go from 0 to 4 billion and then a few numbers, while signed integers can do about half that range, but both in a negative and positive direction. If you do the math, that many frames is just about 4.5 years at 30 frames per second for a frame counting unsigned integer to overflow back to 0. And you may have seen videos like baking a cake for 4.5 years is perfectly acceptable by Strider, because after all, after 4.5 years, the time tracker overflows back to 0 and becomes a much more acceptable duration to bake a cake again. 4.5 years is also 256 times longer than the 6.5 days, which I will take as proof that I am right about not using floats for accumulating values. Though even integer timers have been known to overflow. One very funny consequence of this is that Windows 95 and 98 both crash after just 49 days of runtime because they were counting milliseconds in a 32-bit value. Mario 64's programmers though seemed very aware of potential issues here, and they tried in many ways to prevent issues with the time tracker. Their first line of defense is in the game's actor handling function. This piece of code increments what's known as an action timer for every single actor in the game, resetting this timer when an actor changes their behavior state. For example, a Goomba starting to chase you would update his action to the chase state and reset his timer to 0, and then once his timer hits a certain value, he might stop chasing Mario. But rather than allowing it to climb without a limit, the developers choose a much lower threshold. This timer is not allowed to increment past 0x4 0000000, which in decimal is just around a billion, which is only a quarter of the way to the max value. Which means the timer stops incrementing after about 14 months, which is still a much longer time than a player would realistically spend in an area or even the whole game, but well short of the overflow bug. Without the safeguard, a timer resetting back to 0 after overflowing could trigger a bunch of weird things. But preventing timers from incrementing can break things in its own unique way. Some actors in Mario 64 depend on their timers incrementing every frame for their behavior to work. Certain actions and animations execute precisely every few frames, and actors like the rolling rock spawner spawns a rock every couple of frames, each relying on a timer steadily counting upwards. So, how did the developers address this? Impressively, they anticipated the 14-month bug almost everywhere. Almost every piece of timer-dependent code includes special special accommodations. Take the snippet here. Whenever its internal timer hits exactly 256 frames, it does its thing and then simply resets its timer back to 0, so it never reaches the limit. But of course, in a game as large as Mario 64, with a crazy obscure bug like this, there is no way that there wouldn't be at least one oversight somewhere. Because obviously they didn't spend 14 months in every level to ensure that there actually wouldn't be an issue. So at least one bug was bound to make it through to the final product. They barely even had 14 months to make the whole game. And I actually found 1.5. Let me explain. The first is the Sushi the Shark bug. This enemy plays a sound every 16 frames. It is supposed to sound like this. Yeah, it's not exactly a pleasant sound, but this is the intention. With the music playing and the other stuff around Dire Docks, it blends fine into the background ambience of Dire Docks. Either way, if you spend 14 months on this level, his timer maxes out and he will stop playing his sound altogether. Since usually every time he starts playing the sound he interrupts the previous playback, doing this is actually the only way to hear the full sound effect. So we have kind of unlocked the secret sound effect no one else has heard before in Mario 64, which I think is pretty neat. And the other half of a bug is kind of insane, because this one is only in the Japanese version. This ship here in Rainbow Ride, in the Japanese version only, stops flapping his wings after 14 months because the timer maxes out. Somewhat incredibly, they fixed this bug in the US release and added a sound effect every 64 frames. Whether they fixed it because they looked at the code and saw that this would be a bug, or it just kind of randomly happened as a fix because they wanted to add the sound effect, I am not sure. Still, that is pretty crazy to see. It is already very satisfying to know that these bugs exist, because back in 2015 I've been saying that there has to be some sort of bug from the way the timer is programmed. But actually, there's another timer bug I found that is even more ridiculous. Back in 2015, when we didn't have the luxury of the decompiled source code, only raw assembly code, it was much harder to analyze the code, and I was unable to locate any bugs back then. Now that the decompilation exists, finding bugs like this is as easy as just searching a folder for a suspicious looking code snippet, and that's actually also how I found the previous 1.5 bugs. Now there's one more bug that is much more severe than any we've looked at. Look at this star select screen. Maybe you know that when you first get here and mash your controller's button, it won't let you select the star. In fact, the game makes you wait 12 frames before it lets you select the star. You can move to a different star, but you can't select it yet. And the game making you wait is of course handled with a timer. Funnily enough, we know mostly which parts of Mario 64 were written by which programmer. The star select was most likely written by a different guy than the actual programmers. And it seems that this man did not anticipate anyone would be as annoying as I am being right now. This timer is completely uncapped. And not just that, this timer is a signed integer type. What does this mean practically? Instead of counting up to roughly 4.5 years before overflowing to 0, this signed timer catastrophically overflows after only about 2.25 years of continuous waiting, and the moment it tries to reach 2,147,000,000 and then a couple numbers, the timer doesn't reset to 0. Instead, it violently loops around to the largest possible negative value, which is around -2 billion. And that number is a lot smaller than 12. The consequence of that is that you're not going to be able to select a star for a long time. You would have to wait on the screen for 2.25 years before you can continue playing. And because there's no other way out of this menu, that means you're soft locked for the entire 2 years in this screen with no way out and no visible reason as to why this is happening to you. Do you guys remember the McDonald's Mario 64 machines? I have to wonder if this ever happened on one of those. Imagine being a kid, excited, going to your local McDonald's, and they have Mario 64 and you just soft locked in the star select screen. That would be hilarious. But honestly, yeah, this is a fair punishment for spending over 2 years thinking about which star to select. At least I'm pretty sure that this would happen. I haven't actually let my N64 run for over 2 years to verify this. I had to hack the timer to verify this happens, obviously, so I am very confident that this bug would happen. To my current current knowledge, those 3.5 bugs are all the timer-related bugs hiding within Super Mario 64, but I could be missing some. Impressively, despite these edge cases, Mario 64 handles the passing of time very gracefully compared to many other games. Given what we've discovered, I wonder how many other games have similar glitches. Considering games now run on Delta time, I would not be surprised if in a handful of games, after running them for weeks, gameplay sped up or stopped entirely, or if effects started playing wrong or anything like that. Now that all this is explained, I have a confession to make. While I have pointed out the bunch of issues that this leads to, and while I am aware of all these potential issues, I don't handle any of this overflow stuff either. In fact, I removed the timer limit that Mario 64 uses because I find it to be an unnecessary, very minor performance downside. If you want to spend 4.5 years doing nothing in a level to find a minor sound or particle bug, be my guest, I don't care. I will give you that twisted joy, you sick individual. Anyway, if you know more games with timer bugs like this, please leave a comment. I'm genuinely curious to hear about it. I'm sure there are thousands of games that have these exact same bugs. Shoutouts to Squarespace for sponsoring this video. Squarespace has all the tools you need to build a website. They help you find a domain with one all-inclusive price, no hidden fees, and each domain comes with privacy and security tools. They also offer SEO tools to help your website pop up at the top of Google search. If you like to showcase videos on your website, Squarespace also has the tools for that. You can upload and organize your videos, and if that is what you're into, even monetize or paywall your videos. Go to squarespace.com for a free trial. And when you're ready to launch, go to squarespace.com/Kaze Emanuar to save 10% of your first purchase of a website or domain. Shoutouts to all my Patreons for supporting my channel. If you didn't know, I am also developing my own N64 game while I am making all these videos about Mario 64 and the N64, where I use all the optimizations and tricks I find, and I am going to make the best game that I can make, which obviously I'm going to do that, but I'm gonna try very hard. So thank you very much for supporting me. Bye!